session, we will run something about Terraform, which is nothing but infrastructure as a code. So right now there are a lot of programming languages which are specific to different areas to develop. So Terraform is one of the programming or coding which is going to build infrastructure not only on premises, you can make it on cloud. So now people are more and more towards the cloud. Azure, AWS, GCP, these are the cloud areas where very quickly we want to bring up the environment. That is a overall area. That the whole idea is that. So the Terraform is a tool. It is one of the DevOps tool, and which will help the cloud. So what is this Terraform? How it is formed? From where we got this one, and why we are using Terraform? And we also understand how this Terraform complete flow or architecture or overview is going to work in a different clouds, and little bit command options from our installation. Just show you a small demo. The Terraform will work, and then we'll take some questions. So what is Terraform? So Terraform is an open source software, unlike all other softwares what we have in the CNCF, or if you are going to see something which is available right now in the DevOps market, everything is a open source. So all the open source softwares we are going to use in the DevOps. Most of the time we want to save the cost. So it is based on the infrastructure as a code approach. Infrastructure elements are defined in the one file. The file extension will be in, it is going to have .tf. So it is a simple configuration file. So when you are going to use this tool, Terraform, it is going to read from this .tf file, and then it is going to provision the required resources and infrastructure. So resources in the sense what? You may work on the network, you may be working on the subnets, you may be working on the storage, different areas of your cloud infrastructure. It may be AWS storage, EC3 instance, EC2 instance, or if you are going to see S3 buckets for storage, or if you are working on the root 53 or something where you are going to use the IP tables and subnets will be created for the project. So if you need bulk, this is the best option. You just write what you need. You just tell in one file, one configuration file, that .tf file, it will make it available for you. So Terraform is a simple language. You declare something, you describe something which you need required for entire project. You can set up development environment within fraction of seconds if you have a cloud account and you have a requirements completely clear. So one is clarity on what you need to deploy, where you have to go, which number of instances you want to create, virtual machines, Ubuntu instances, or CentOS instances, or Oracle instances, what you want in that particular cloud. You tell that it is going to work. So when you're working on the AWS or any cloud instances, free tier is having limitations. Remember this point. So limitations for the routing capabilities, limitation for the your storage S3 bucket. So there is, each one is having some limitations. So if you have the account, then if you have the full access like GCP, you're going to have full access, or if you go for the Azure for 1 month, it is also full access you are going to have to practice some of the tests. You can do it on that. So what Terraform is going to work for? Terraform is having a simple life cycle. You are going to start from one simple plan. If plan is correct, then you can go for the applying. If it is applied successfully, then it is going to create all the resources which you expressed as declared or described in your TF file. Once it is deployed, work is completed, you can destroy that one. And if you want to create again similar kind of environment, test QA, today we have test, then we build that infrastructure and give it to the QA team. Once they are completed their testing, then we don't need that previous environment. So in such cases, we can destroy those unnecessary, unused resources on the internet or in the cloud. So how we can destroy? That is again, you have the TF file only. So one phase after the another phase, you can just simply go on, and once everything is done, then again you can refresh with the new versions, new releases, new code. You can get it into the Terraform. So that is how the Terraform is going to work. So what are the special features? Why we are going to have Terraform only? There are a lot of other options also. Every cloud, they are having their own specific CLI tools. If you look at the AWS Foundation formation tool is one of the tool that will work only in AWS. Azure is also having templates. So templates will work only in Azure, that we cannot use in the AWS. So if there is a project that is working on Azure and AWS or some Oracle Cloud or IBM Cloud, then how it is going to work? So Terraform is a solution where you can work with multi-cloud environment. Within the same TF file, you can tell that Azure, I want this many sub networks, this many I want storage, this many instances, virtual machines I want. Or in AWS, you are going to say T2 or T3 tier or micro size of the instances you want. So you can mention that, and you can create a TF file. In one single file, you can run that one, and you can get it available on the cloud. Only thing is, you need to set up your cloud account configuration available to the Terraform, so that it will launch those infrastructure as a service or software as a service clouds. So these two areas most commonly Terraform will be used. There are a lot of code syntaxes, how we can maintain the declarative and domain specific changes. So you can take the provisioner's help on that. You can use Chef, Ansible, or you can use Puppet. So those are the tools which are going to maintain the configuration management. And it runs on any platform. The Terraform will work on Windows system, it can run on Linux system, it can run on Mac OS also. So it is an open source, absolutely free. You just go to the Hashika website, you can download Terraform. So as per your machine, as per your platform, you need to choose that one. Windows machine I have, then I am going to select the Windows 64-bit Terraform. It's some small IaC file. If you run that one, it will be available on your path. In your command prompt, you can access the Terraform commands. So why Terraform? Terraform, if you compare with any configuration management tool like Chef and Puppet, do we need any agents? Do we need to have install something on the every VM or every something? Is it? No. So Terraform doesn't require such kind of thing. Terraform require only access authentication of your cloud, so that you can build entire infrastructure. So Terraform is like CloudFormation, which is available in the AWS. Heat, it is a generic, but Heat is not that popular as the Terraform. Heat is also open source, that is from the Apache license. And Terraform is also having special capabilities. What Boto, Fog, these softwares, how they are going to work, similar kind of capabilities which you can work on. And it is more customized solution for the infrastructure. You can work with the routing, switches, networks, storage, and your infrastructure instances. All of them you can customize in one single file, and you can make that one single TF file. Okay. If you compare this different tools, why Terraform? comparing with the any other infrastructure capabilities or infrastructure as a code. The first thing, if you are going to see, it will work on any cloud. That is the first important aspect. So infrastructure, there are different types of coding capabilities, mutable and immutable. So if you see Chef, Puppet, Ansible, these are all mutable. So you cannot immutable means once it is provisioned, once this is done, you cannot change. So which one is that one? So if you see mutable and immutable you cannot change. Mutable you can change, you can modify, reconfigure, provision. So Chef, Puppet, Ansible, that will redo or reusable things done from the infrastructure level. But if you see Terraform, Heat, CloudFormation, these are all immutable structures. If you look at the configuration management purpose, you have the Chef, Puppet, Ansible, but this Terraform is not configuration management tool. It is an orchestration of clouds, a cloud or multiple clouds. So if you look at the Heat and CloudFormation, it is limited to AWS. If you are going to see architecture wise, there is a client server required for the Chef. Chef, if you are going to work, there is a workstation in the Chef, and there is a Chef master there you are going to connect. So similar structure, agent and Puppet server will be there, and Ansible is going to work client only side. So if you compare Terraform and Ansible, it is going to work from the one particular host mission from where you want to run. That is the thing. So Ansible is also working in the similar fashion. Okay, so virtual machine provisioning is partial in the Chef. It is not going to provision actually. It is helps to provision with the some other tools. So Puppet, Ansible, these are all not capable to create any VM. They are helpers or provisioners. They will be once that VM is created, then this script will be executed. Okay, so Terraform and Heat and CloudFormation will work for the virtual machine which is created on the cloud. The network which you are going to use, the Chef, the partial and if you see all these configuration management tools, they are partially work for the network. But whereas Terraform, Heat and CloudFormation, all these network structure or subnets or routing, IP tables, everything you can configure and tell this is the IP address range I want to use it for this project. You can mention that, you can work with that. And similarly storage also partially you can tell that one VM this many CPUs I want to use, or this many GB of memory I can use from the Chef or Puppet and Ansible, but you cannot control that one. So that controlling is there in the your this immutable tools. Okay, so there you can mention the configuration that will be actually working on the cloud, and you can get the storage from the S3 in AWS or GCP storage or virtual disk, or in your Azure virtual disk where you can get the storage space. You have large community. If you compare with the helpers, who is going to help on this particular tool if I'm going to use, then the first thing most people are looking for, where there is a more bigger huge community, then I can get somebody will help us on whenever you get some trouble. So you can post some question and somebody will answer that one. So if you look at compare with the configuration management tool, Ansible is biggest huge, and in our immutable infrastructure as a code tools, the biggest huge one is your Terraform community is a huge community. So that is the advantage we can get it from that. Okay, so why Terraform? These are the important aspects, key points I think you got from this page, this slide. And yeah, coming to the how it is going to work in real-time projects. So Terraform is one simple code which you are going to write. So Terraform is going to have .tf file. You can write everything in one TF file. But if you want to distribute something, you want to tell that what is the state you want to maintain for virtual machines or instances which you are going to bring up on your cloud infrastructures. That you can tell in the Terraform.state. Some variables which you want to use, like network subnet, or if you want to go for the storage, what is the name you want to give for each domain. So all these things you can define in the TF variables, vars, TF vars. So Terraform providers, there are different providers. You can see in the right side, AWS, Azure, GCP, Oracle Cloud, or OpenShift, VMware. So all these are different tools which you are going to have provisioners, providers, which you can use in your Terraform. You can create the instances, any resource you can handle. You can just use the simple flower brackets and tell that this is the name, this is the tag, and this is the how much you want to use, the range. So these are the simple definitions which you can define in your files, and Terraform will work for you and provide a complete infrastructure as a cloud or cluster, or what you want to use or where you want to use. That depends on your requirements. Okay, so that is about how Terraform is going to work. So one simple example, if you are going to see how the Terraform file looks like. So if you look at the provider, one provider, if I'm going to say AWS. So AWS provider, if I'm going to use the region US West, I may use in India, South Asia, or Asia Pacific. So there are different regions, and we can select that region, and then you are going to tell the AWS AMI what instance you want to create. So one virtual machine, Ubuntu virtual machine I want to create. Then what are the filters? What is the name on my image? How we are going to associate? So these values we can get it from the AWS. Previously, just trial and error, we are going to create something. That server information, we can use it to create the new Ubuntu instance. So here in the example, Ubuntu Trustees 14 version is the old version, but that depends just how free tiers are available. So this is one of the free tier available. So I'm just showing the simple example for filtering that instance. So you can virtualize VM, so HVM, which you are going to use in AWS. The resources, AWS instance, which you are going to use for the web application. So this is one simple application which we are going to use. So instance type is T2 micro. So if you go into the first provisioning of your service, then you're going to tell what type of AMI you are going to select. T1, T2, micro, macros, small. These are the different sizes which you are going to have. So out of that, if you select, then you are going to get this one. And you can also use the variables which you are declared. So if you see here, data.aws AMI Ubuntu. So that hierarchy, whatever you declare, that will be used as a creation of the resource. So this entire structure we have defined from this place only. So when you are going to provide the data to create the resource, first we are going to use a plan. So Terraform plan will check this entire syntax is correct or not, or whatever the connectivity is successful to the R access. Then it is going to tell everything good. Then we can proceed on the Terraform apply, so that this instance will be created on your AWS. Okay, so this is one simple example where you can create one VM on the AWS cloud. Similarly, we can have it on the, in place of AWS, you can use Azure. In place of AWS, you can use GCP. So different clouds you can use, and different naming conventions and types, the resources which you are going to use. Okay, so this is a simple example which you can see. So when you're going to build infrastructure, in making the infrastructure, we are going to use the complete cloud, and then we are going to see, if you are going to start from the beginning, first in the AWS, we are going to create VPC. Then we are going to create the instance, EC2 instance. Then further, if you want to go for more and more instances, you can create EC2 instances, or you can go for the network, or you can go for the storage S3 buckets. So these are the general requirements. So cloud requirements will be defined in your TF files. Sample TF is one example if you are going to see. The variables what just we have defined, similar to that, we can define you are allowed to access what kind of instances that you can define there, and you directly use them with the dollar. Just like in a shell script, we are going to access the variable values if it is already defined. Same way, whatever you define in the TF vars, that will be accessed by the dollar, then followed by the variable which you are declared here. Okay, so this is a one flow where you can create your instances, and you can build complete internet infrastructure for your project. So once this infrastructure is created, but who will start? So that is a desired state. So Terraform is going to have a TF state. That state will be maintained by any configuration management tool. And right now, most popular configuration management tool are speedily developing or simple to read, that is Ansible. So if you are going to use some playbooks, you are going to tell the configuration. So I want in the EC2 one Tomcat server should be running, or web application will be up and running. So if you tell this to the Ansible, and that will keep running in this one. Or if you are going to tell that Ansible, please create a container in this EC2 instance, Docker install, and instance image will be created, Tomcat instance or whatever the web Docker images will be pulled, and you can run that one. So everything from the files, it will be created, and your cloud will be up and running, your application will be available. You can simply deploy the application. So you can just change the version, and you can get the latest version into that one. So that is how the build and repeatable infrastructure you can make using the combination of Terraform and Ansible, or configuration management tool. Okay, this is the overall requirements in the current projects. So the managing Azure, or if you look at Azure infrastructure, Terraform is having complete capability to handle all the different tools which are available on the Azure. So where you can access the analytics, you can access the provisioning of the network, or you can create the secure groups, you can create the instances, VM instances. So everything is under control, or you can write in a TF file, and it will be working as a DevOps tool, Azure DevOps tool. Okay, so overall, what we are going to learn out of this course, we're going to build one development environment. First, what are the resources, one Linux environment from where, how we are going to set up. Then this development environment, we will start getting understanding about the provisioner concept. You want to provision a AWS resources, or you can work on the GCP, or you can work on the Azure. So that depends on preferable options for you, whatever on which project you are working. Then coming to the Terraform modules, these are the different options, different resources which you are going to work. Accordingly, we have to learn about each module. So if you are working on the data source, data stores, then that related modules we need to understand how to use those attributes, and how to use the syntax completely about that. Once you get into that completely deep dive, then we can work with if it is a AWS, then DynamoDB or S3 buckets, policies, ACIs, ACLs, one website setup, how we can do that practical thing, we can do it on this fourth session. And then we work on the network VPC. So in any GCP or a AWS, first thing we are going to create the virtual private network for your project. So how many you want to keep in a public subnet, or how much you want to build for the private subnet, how the route table will be work, how it is going to link with the private subnet and public network. All this will work with the Terraform script only, and that will be creating on the AWS cloud. So in public IP address, if you are going to work with Elastic IP, so Elastic IP is a public IP address for a website. One entire project will be having the one entry point, and how we can link that one with the NAT and route tables which we have, and how the internet gateway will be accessible, or how you can open for the project. Those are the best implementations which we can do it on the EC2 instance. And if you are working on some other cloud, then we look for that options, how we can, but the concept is same, public IP, how we can link up the routing process. And then validation and cleanup. So once the work is completed, how we wrap up or close or destroy your environment, that best practices. Is there any requirements for backup of your project? What are the things which we can work on? So what is the reuse strategy when we are going to do the complete infrastructure is ready and test is completed? So that is the last area which we can cover. So that is all about what is Terraform and how we can learn, go further. So next level of Terraform, where we can go, that is simple Terraform advanced concepts and Docker concepts and Kubernetes cluster or AWS Kubernetes cluster or Terraform CLI, Terraform cloud infrastructure building. So those are the things which we can learn in further learnings. So overall course high level, what we are going to work on: installation, configuration, defining Terraform files, Terraform plan, apply, deploy resources, different resources on different platforms, what is the state, and how we can get the graph, Terraform graph, repository, and create the Terraform with the Docker file. So that's all about from my end. So if you install in your Windows machine, you can see yeah. So from anywhere you can just do Terraform, and you can see version. So this is a version where you can install. So it's a just exe file, and if you keep in the path, then Terraform version you are going to get there. And it is very straight, simple commands where you are going to use the Terraform help. So all these are the commands: Terraform apply, Terraform graph, Terraform whatever I just told you. So first thing is Terraform plan we are going to run. And then we are going to use the apply. Whenever you want to apply, infrastructure is ready, then we are going to apply it on that. Okay. So far this is my idea, overall idea of how we can proceed on this Terraform learning. You have any requirement, Nagesh, for your project, on which cloud you are working?
Yeah, I'm working on AWS now. So
yeah, so that is targeted correctly. Okay, good.
Yeah, as of now, I'm working to build an ALB module. Yeah, I have a very basic understanding like how it works. I mean, the Terraform, very basic understanding. Recently, I started.
In your project, you have the AWS account, and you can access all the configuration resources, right?
Yes.
Okay.
I have all the environment available.
Okay. Okay. So when we work together, you can share your screen and you can work on your sandbox environments, development environments, anything which you have.
Yeah, we can do.
Yeah, on weekly basis, we are going to have a 3 days session, and we can have this one around 15 sessions, 7 topics actually. So 7 topics we cover overall, and in between we can also discuss with your priorities, requirements, how you are going to work on day-to-day activities, plus what we are learning continuously. So I just planned for the 7 topics, and then parallelly we can also. Uh, Hello, Hari.
Yes, sir.
So, you have any idea about Terraform? Did you install or you started working on it?
Yeah,
AWS
I have basic idea. Yeah,
you have. Okay, good. Yeah, so that is what we are targeting. So if you are interested on GCP also, yeah, that is also well and good. We can work on multi-cloud actually. So Terraform gives that option.
okay.
You can create a network here and we can work on AWS also. So together, one TF file will work on two different clouds. So multi-cloud is supported from the Terraform. That is the greatest advantage. So two consoles, you want one thing you write, and two consoles will work on one single go. So if you have 2 accounts, GCP account and AWS account, that will be much bigger testing environment which we can build. Anyway, yeah. So this is just basic demo about what we are going to learn in this one and how we can proceed. Thank you, guys. Thank you, everyone.